Okay, midpoint, easy peasy, we found it. We did the application of midpoint where we do the reverse, both of which are going to be asked or can be asked. Distance was the straight up finding the distance. The application is when I give you the distance and you must find the missing value. And it will almost always refer and send you to a, actually not almost always, it will always be a quadratic equation, which means a trinomial factorizing and finding which one fits the point on the Cartesian plane. So I would have to give you the Cartesian plane so that you know which one it is. So I know we did it the other way around, but that's not the end of the world. Then I gave you this one to practice. Finding the midpoint and the distance if I give you A and B. So it's x of A minus x of B squared and y of A minus y of B. But y of B is a negative and that's why we have protected it. Also, my calculator does not like mixed fractions. It doesn't do well with them. So I had to change it to a improper fraction before I could square. Then I can type the whole thing into my calculator, but I do need to see this on your paper and then get an answer to 2 decimal places. My midpoint would be x of A plus x of B divided by 2 and y of A plus y of B dividing by 2. There is the plus from the equation, but the point itself is negative, so I had to protect. There it is in improper fraction form. There it is in mixed fraction form. I could also ask decimal form. It depends on the instructions. If I had to do decimal form, which is the least accurate because I'm going to land up rounding off on this one, it is still possible. So I'm going to do it in red because I don't know where green is. So it would be negative 2,75. And this would be negative 11. I think it's 875, but I could be wrong. Yes, 875. So it would be negative 11,875. But normally we do things to 2 decimal places, so we're losing some accuracy, but we would round off to 8. All depends on the instructions what answer you give me. If I don't give you an instruction, then if it's whole numbers, obviously make it whole numbers. If you have fractions, then do the improper or the mixed fraction. Any questions? Okay, go moving on to our straight lines. I don't feel like working in red anymore. Working blue. Okay, we are still 10.5 and it is Wednesday, group 1. Oh, my blue folky is dying. The stuff we're doing today and tomorrow, yes. Okay, is anyone still busy with what is currently on the board? Okay. Finished? Okay. So we are sticking to or starting with gradients today. There are going to be 4 main parts to gradients. Obviously the formula for gradient, calculating gradient. How do gradients act if there are lines that are parallel? How do gradients act if there are lines that are perpendicular? And collinear points. These are the 4 main topics under gradients, and we will obviously flesh each of them out. So starting with my formula. My symbol for gradient is m, and we call it the growth of y, or the change of y in the growth or change of x, which is basically just the difference between two y values divided by the corresponding difference of two x values. But the y is always on the top and the x is always on the bottom. Once again, a gradient that you need, not a gradient, a formula that you need to know will not be given to you. But we've been doing this since grade 8. So we take the 2 points and we substitute in the values. The most common mistakes, or 2 mistakes, one is putting x on top and y at the bottom. The other one is not keeping your coordinates together. So very NB, keep the xy pair together. That means, I'm doing pencil, that the xy top bottom is a pair and must be kept together. So that would be x2 and y2, and that would be x1 and y1 from the coordinates that I've stolen from the plane or the information. Now a gradient is not just telling me about slope, it's not just telling me how flat or how steep a line is. When comparing graphs, I can tell certain bits of information. If those graphs look identical in their slope, we call them parallel, therefore their gradients are the same. So parallel lines. My gradient of my first line is equal to my gradient of my second line. Or two lines that are parallel have equal gradients. Just writing it in words for you from the formula. Two lines that are perpendicular, we say they are inverses of each other, negative inverses of each other. It means that we swap the sign and we flip the fraction. So perpendicular lines, and there is a formula telling me that if I take gradient 1 and I times it with gradient 2, then the answer will be negative 1. I'm going to write that in words. When two lines are perpendicular, multiplying their gradients will always equal negative 1. So if I take two lines and I multiply their gradients and the answer is not negative 1, then simply they are not perpendicular lines. Say it again. If the gradients multiplied together are not negative 1, then they are not perpendicular lines. So I'll just make a note here. Therefore, if I take two gradients and multiply them together, and answer is negative 1, then they are perpendicular. not -1, not perpendicular. Sorry, it's very ugly at the bottom there, but I just ran out of space. So when two lines are perpendicular, multiplying their gradients will equal -1. Therefore, if I take two gradients and multiply together and the answer is -1, then they are perpendicular. If the answer is not -1, they are not perpendicular. As simple as that. So if I had to ask you, is AB perpendicular to DC, I need the gradient of AB, I need the gradient of DC. Is the answer of the product -1? Yes, they are perpendicular. We'll do an example after our notes. Anyone busy? Okay, I'm going to move it up, so hopefully you are on perpendicular lines. Okay, so the next one is collinear points. M of 1, 2 equals to M of 1, 3 is equal to M of 2, 3. That means that if I have 3 points, calling them 1, 2, and 3, I have to find all 3 gradients of all 3 combinations, and if they are equal, then they are collinear. So in words, collinear points are when the gradients of each combination of points are equal. So when the gradients of each combination of points are equal. Let's look at what collinear means. Co means together, linear means straight line, so together they form a straight line. So if they form a straight line, that means they have to be on the same line and therefore have the same gradients. So co, together, linear, straight line. Therefore, collinear points. You still busy with perpendicular lines? So you're on the last part. Okay. Points that together form a straight line. I remember in the beginning of the year you guys really struggled with this concept. So points that together form a straight line. If on the same straight line the gradients have to be on the same, or be the same. If on the straight line, then gradients will be same. And very important, we are talking about them being on the same straight line, not creating a new line, the same straight line. So now we can just start practicing. We'll first do a practice involving all the gradient stuff, and then we'll put everything together. Okay, giving some time to finish writing that. So I'll stick to doing my activity in words. When I put everything together, I'll put it on the Cartesian plane. Still writing notes? Anyone? Okay. So hold on. Yes, you done? Yes, you can. Okay. I'm just finishing this example so it actually works. Okay, so I have two lines. So exercise on gradients. I have two lines, AB and DC. The points are as follows. A is 2 and negative 4. B is 6 and 12. C is positive 8 and 4. Negative 4. And D is 12 and 12. R, A, B, and DC parallel.
Minus 12 and just the 12 at the end?
12 and 12. Okay, should be done. It's a very quick, easy sum. Only took me that long because I was busy writing the next question. Okay, so my first thing is I actually need to find my gradient of AB and I need to find the gradient of DC. So y of B minus y of A, protecting the negative. So then I took that y first, so that must be that x first. X minus 2 at the bottom. 12 plus 4 is 16. 6 minus 2 is 4. 16 divided by 4 is positive 4. DC, taking 12 minus minus, protecting the negative 4. And the same D first, 12 minus 8. 12 plus 4 is 16, and 12 minus 8 is 4, and therefore still a positive 4. Gradient AB is equal to gradient DC, therefore yes, they are parallel. A nice easy peasy question. I can only hope that's the kind of question that you get. My next question that I'm going to ask you is, I now introduce a third line, EF. Prove that EF is perpendicular to both these lines, and note that E has that coordinate and F has that coordinate. Please do not just wait for the answer. Definitely not helping you in that test that's coming up. Okay, so I am talking about EF and I'm talking about perpendicular. So the first thing I'm doing is finding that gradient of EF. If nothing else, do that and you can get some marks. So EF, I'm going to go F first, so minus 4 minus, protect the negative, 5, 9 minus 13, negative 4 plus 5 is positive 1, and 9 minus 13, negative 4, so my gradient is negative 1 over 4. Now if I want to prove that something is perpendicular, multiply the gradients and see if it equals to negative 1. Does it matter which line I used, AB or DC? No, they are both parallel to each other. So if I take one of their gradients and prove that it is perpendicular, then it will be we will prove that they are perpendicular to both. So I'm going to say negative 1 over 4 times any gradient from AB or DC. My answer is negative 1. Therefore, EF parallel to both, perpendicular to both lines. If that answer was not negative 1, then it would not be perpendicular. And my last question before I start introducing some Cartesian planes. How come the lesson always flies when it's with you guys, but goes so slow with everyone else? She was... Yeah.
What do you mean? Remember I thought you was like, because you all the time teaching, so...
But I am always teaching with them as well. It just feels like forever. But we have 7 minutes, 7 to maybe 10 minutes, and then it's break. Okay. Anyone still writing that? Or at least can I move it up? My last question, I introduce a fifth point, or I introduce point G. Is it collinear to A and B? Note G is 4 and 8. So I introduce point G. Is it collinear to A and B? Note that G is 4 and 8. What did we write on collinear? We wrote that every combination of points, gradients must be equal. That means if I have A, B, and G, I need to find the gradient of AB, which we've done, gradient of AG, which we will need to calculate, and the gradient of BG, and find if they are equal. So we'll just make a note here, we'll do this one together. If collinear, then MAB will be equal to MAG, which will be equal to MBG. Which means we actually need to know what the gradient of MAB is, the gradient of AG, and I need to know what the gradient of BG is. We already have AB we calculated as 4. So what you need to do now for me is calculate AG and BG, please. Getting lots of gradient practice in today. So I guided you on that one. Obviously in the test I would not be able to do that. You're going to have to refer to A and B. I'm just going to freeze.
Have your attention, please. About the auditions taking place upstairs in the D wing today at 1:15 for the Joseph An Amazing Technicolor Dreamcoat production. Prepare a song. Reminder, the auditions will take place upstairs D wing at 1:15 today. Thank you.
Okay, so I calculated gradient AB earlier, it is 4. I recalculated AG, I already saw that it wasn't going to be the same, but for the in sake of completion, MBG also not the same, so I finalize. This is a perfect answer, therefore gradient AB is not equal to gradient AG, is not equal to gradient BG, therefore they are not collinear. So tomorrow we're going to do all of this again, except the words will be on a Cartesian plane.